Hello everyone. So today in this video lecture in the series of computer system architecture, I am going to explain you the concept of de-multiplexer. De-multiplexer is also known as data distributor. It has one input line and it distributes this input into 2 raised to power n output lines. Here you can see in this example I have 1 cross 4 demultiplexer, because I is an input and the output is it produces or it distributes 4 output y0, y1, y2 and y3 with the help of selection lines. Okay, so here n is the your selection lines. So if 2 selection lines, then it will distribute this single input into 4 outputs, and if the value of n is 3, which is the selection line is 3, then it will distribute this one input into 8 outputs. Okay, so let's see what will be the truth table for this 1 cross 4 demultiplexer, right? So here I write the input, and here is your selection lines, which is S0 and S1. Here is your output lines, which is 4 in your case, right? So let me write O/P, which is input, and I/P, which is input, right? So this is input, this is output, and these are the selection lines. So let's see how to write the truth table for the demultiplexer or the data distributor, which is for 1 cross 4 demultiplexer. Here for these 2 selection lines we have 4 combinations. Okay. 0 0, 0 1, 1 0 and 1 1, right? So, and the outputs are for 0 0, it will distribute input to I0, sorry, y0, because I have taken I as an input, so I cannot use this symbol for this, right? So this will be y0, right? And the all others will be 0 0 0, right? Because it will produce 4 outputs. So for these 2 combinations, the y0 will be selected, y0 will be distributed, and the all other outputs will be 0 0 0, because these 3 outputs will be 0, because y0 is distributed, I is distributed to y0. So when I is distributed to y1, then y0, y2, y3 will be 0. So in that case, when S0 is 0 and S1 is 1, y1 will be distributed and I is distributed to y1, and all other output will be 0, right? And when we have this combination, when S0 is 1 and S1 is 0, so I will be distributed to y2. So these all 3 outputs will be 0, which is y0, y1 and y3 is 0. And in the last case, when both selection line is 1, right? So in that case y3 will be I will be distributed to y3. So all other output will be 0, right? 0, 0 and 0, right? So this is your truth table. This is your truth table for this 4 cross 1 cross 4 demultiplexer. Here now we talk about the input. So what will be the input? So in all the cases the input will be I. Input will be I. Okay. I will be the input. So in different books this input is specified by using different symbols, or in some books you will see, or on some websites, as you search in Google that for demultiplexer they have written 1 1 1. Okay, 1 1 1 1 in place of input. So it's not identifies this one. Okay, these ones are not identified with this one. This one is the number of input, right? This one is represent for number of input, or number of input will be 1. So we can say this is this one represents single input. Single input. So don't confuse with I and this one. Okay, don't confuse with this. This one referred to as single input. So you can say that the demultiplexer is single input and multiple output combinational circuit, which is the reverse of the multiplexer, where multiplexer is the multiple inputs and single input, but demultiplexer is the single input and multiple output combinational circuit, right? So but I will write only input is I, because input can be any of the, it can be a 1, it can be 0, right? So because with the help of these selection lines, this input is distributed to these outputs, right? So how to write this combination? How to write this combination? So we will write as y0 will be written as I will be the same because the input is single. So the value of I will be same for all, in all the cases, right? So I, and then S0 and S1. S0, S1 is, you know that when we write 0, we take complement of this. So S0 complement, S1 complement I, right? So either you write like S0 complement, S1 complement I, which is the dot product of these, right? So that means the AND gate will be between these two, between these three, right? So these three inputs, right, along with the, because why I am saying that these three inputs, because this input is combined with these selection lines to distribute with one of these outputs, right? So I have written S0 complement, S1 complement I for this, or you can say I, you can write I, S0 complement, S1 complement, right? This is the same. If you write I before this here, or you write I here, so because it's like a traditional thing to write this Boolean function, that we write selection lines first and then we write this input. So that's why I am taking this, because most of the students can be confused from this function, right? Because in some in multiplexer I have I have taken the selection lines before this input gate, right? So that's why I'm writing S1 S not complement, S1 complement and I. And for the Y1, because here we have the 4 outputs, so what we have to do, we have to write the four Boolean functions for each of the outputs for Y0, Y1, Y2 and Y3. So for Y1 it will be S not complement, because S not or S0 is 0, so we will take the complement, so S0 complement and then S1, right? So here we write S1 and then I will be the same for all the outputs, right? Then for Y2 we need to write this combination, S naught is 1 or S0 is 1 and S1 is 0. So we will not take the complement for the S0 in this case, because S0 is 1, and we will take the complement for the S1, right? So S1 is S1 complement, and then we'll take we write I with this. Okay, now for the Y3, this Boolean function will be S0, S1 and I, because both S0 and S1 is 1, the last case, right? So S0, S1 and I, right? So here we have this I. Okay, now it's very easy to design the circuit for this de-multiplexer or data distributor, which is 1 cross 4 de-multiplexers. So let me write this for each of the Boolean functions, for each of the outputs, right? So take this. So it's very easy when you write, because what you have to do, you have to write for S0 and then for S1, and you can as well use the I symbol here for each of these combinations, because in multiplexer what I did, or what we used, that for I0, I1 and I2 and I3, they were feeded into the AND gate. If you remember, if you don't remember, please do watch the video lecture on the topic of multiplexer and see the difference. So for S0, we have to take the complement and we will take the S0 directly. So we will use this as both the forms, right? So both the forms. So we have to take the negation, and or we have to take the complement, as well as it will feed it in two cases directly. So we'll take the straight line for S0, and here we have the S0 complement, right? Again for S1 we have to take both the cases, because S1 is will be taken as the complement in these two cases where S1 is 0, right? And in two cases we have to take the S1 directly. So that's why we have to take this both the forms, right? So it will be negate, because it's a inverter, and if you don't know about the inverter, so please do watch the video for the logic gates. Then for the I, we have this, because I will not be negate, or the complement of I will not be taken in either of the cases, because we have taken the I, because this will take I as an input. Okay, Now for y naught, because we have four outputs, so we have to take the y0, right, or y1, for y2, and for y3. So I have to increase the length of these inputs, right? So it's very easy to draw a logic circuit for each of these cases. Okay, so for the multiplexer and demultiplexer and for encoder and decoder, you need to take this kind of representation for these inputs, so it will be easy to draw the logic circuit. Because here so let's take this Boolean function y0, which is s naught complement. So s naught complement, and s1 complement, and then I, right? So for this we have because this is the sum of product form, or we can this is sum of product form. This is actually a minterm, right, which is 0 0 1, right? So this is the minterm, and it will be directly fed to the AND gate, right? So this is your AND gate, and they are fed to this AND gate because they have the dot operator between these, and we know that this dot operator, or the hidden dot, is, or the multiplication of the product of these three inputs are represented with the AND gate. This is the AND operation between these three variables, right? Or you can say in these words, right? So this is y0, and for y1 we have s naught complement, right? And we have this s1 and I. So s1 is here and I is here, right? So it will represent your y1 output, which is again used with the AND gate, because these three variables are or used the AND operation between these three variables, right? So for the y2 we have s naught, s1 complement, and I. So s naught or s0 is here, okay, and we have s1 complement. So s1 complement is this, and we have the I. So I is here, right? Then again we will use the AND gate, because these three variables are combined with the AND operation, and for this we have s naught, s1 and I. So s naught or s0, s1, right? S1 is this, and I, right? So so we have these again with the AND gate. So this is it's a logic circuit for the de-multiplexer. So again, if you try few examples to draw the logic circuit or the truth table, so for other configuration of de-multiplexer, like 1x8 or 1x16, so let me explain you the 1x8. So in 1x8 it will be like 2 raised to power 3. So there will be 3 selection lines. So you have to introduce one term here, S0, S1 and S2, right? And the output will be Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. Here this table, the S2 will introduce here, and then you need to consider the combination of 3 bits, right? So this will be S0, 0, 0, 0, 0, 0, 1 and 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1 and 1, 1, or 0, 1, 1 and 1, 1, 1, 1, 0 or 1, 1, 1, right? So that will be some combinations for the 1 cross 8 multiplexer, demultiplexer, sorry. And here we have this representation will be S0, S1 and S2. S2 will again introduce here, so that will be only the difference, and we have the 8 outputs, right, in that case. So this is all for the demultiplexer. You have any query and how the questions are asked from the demultiplexers, and so you can message me, you can write the message in the comment section. So thanks for watching.